Alright, the first part is a review. Y'all should know how to do this. It's really frustrating not being able to zoom on here. So for this first one, is 32 a perfect square? No, but what's a perfect square that goes into 32? Good. 16 how many times? Do we have to break up x to the 8th? Because it's what? Divisible by? Good. Or an even number. Very good. Alright, so tell me how to simplify this. Square root of? What are we missing? Very good. Go ahead and do 2 on your own. Again, this should just be a review of 6.4. I just put these on there so we wouldn't forget. I know last week was crazy. Y'all want to know why he's so loud?
He's got a speaker.
Oh, I want to.
He's not using the microphone. That's just his voice.
Microphone's the wall.
That's just He's not using the microphone.
I'm so
You have to give it a second.
She goes, she's like, Cordell, wake up.
That'd be too funny. I think I'm.
You want to have battery?
I'm on enough.
You gotta have battery.
Hello. Oh, there it goes. I'm on enough, I don't need it. Alright, are y'all done with number 2? Okay. Alright, somebody, final answer for number 2.
Plus or minus 2c cubed e square root of 3.
3 what? Okay. Everybody agree? Any questions? Do number 3. Alright, David, what do I break 24 up into? Why?
Because 8 is a cube.
Very good. Perfect cube. Cordell, what do I break 8 to the 6 up into?
8 to the 7.
Good. Why do we leave it? Yes.
I was confused in the beginning because I thought when it has a third root that you have to take out something that's to the root of third.
Nope. With exponents, you just divide by whatever this is. So if it is divisible by 3, which 6 is, we can leave it. But b to the 8th, Caroline, we have to break up into what? Very good. And c, we obviously can't do anything with because that exponent's smaller than 3. So tell me something that's going to be on the outside.
2
Next.
a squared
Next.
b squared.
Anything else? Alright, so it'd be cube root of.
3
Are we missing anything? No. Why not? Because it's an odd root. Very good. Alright, last one. Go ahead and do that one on your own. Shouldn't take you long on that one. Alright, Aaron, what do we have to break 16 up into?
2
good. I know where you got 2 from. But do we have to break this up like we did on the first one? Because it's a what? 4th root. Darrell, do we have to break 8 to the 24 up? Why? Divisible by 4. We have to break B up into what? Good. Final answer? Plus or minus 2a to the B and 4th root of B. Very good. Do we have to do any more of those? Are y'all good with those? Okay, so I won't make y'all do the guided practice below since we're good with simplifying. And y'all did pretty good with those on your tests. Some of y'all were struggling, but most of y'all did good on those. Alright, we are going to do like this part tomorrow with a checkpoint. Right now we're going to start on adding and subtracting radicals on the back. Adding and subtracting radicals. Alright, so could I add x plus y? Why? Yes. Okay, could I add 2x and x squared? Because they have different what? Exponents. Good. Okay, so with radicals, you don't have to write that part down. They have to have the same, make sure you write this part down, same root and same number under radical. Same root and same number under the radical in order for us to add and subtract. Add and subtract. If they don't, we just leave them like they are. Just like this one, we couldn't add x plus y, so you leave it like it is. So like on number 1, did those have the same root? Careful. What root did these both have? 2, right? Square root. They both have the same root. Oh man, y'all had each other's papers. Thanks. Sorry, you named you'll have special ones. There you go. Alright, so they have the same root. They just don't have the same number underneath the radical. This one has an 8, this one has a 50. How can we change that? Anybody? What did we just get done doing? Breaking it up. Good, Ashton. So what can we break the 8 up into? Very good, because 4 is perfect square. Any perfect squares that go into 50? 25 and 2, very good. When I take the square root of this 4, which is 2, what am I going to do with that? Multiply by what? So that would make 8 root 2. I think you squared it. And then what right here? Perfect root 2. Now do they have the same thing underneath the radical? Yes, so if they do, you just add their coefficients. So what's 8 plus 15? And you keep square root of 2. That's it. And you can check these in your calculator. I'll show you how in just a second. Questions about that one? Alright, let's start with this next one. 98. Tell me a perfect square that can go into 98. Somebody say 2. 36 times what? 36 times 3. Good. Alright, what's a perfect square that can go into 32? Times what? 2. Very good. Alright, so 36 times 3, that would turn into what?
That's not 98. That's not
Correct. That is not 98. Let's go back.
I said 50.
But,
48 and 2.
what now? 49 and 2. Now, if you're having trouble figuring this out, like with bigger numbers, if you look at this and you know what you're taking out, there's going to be a 2 left right here, right? And we want a what left right here? A 2. So you could just divide this by 2 and see if it's a perfect square. Usually that works out. Does that make sense? Okay, so this one will turn into 7 root 2 minus Good. 8 root 2. So that would leave us -1 root 2. Very good. Here's how we check it. Can I borrow this? Okay. So if you have a calculator like this, or I think any calculator will do it, let me show you how to check this one. You just type in 4 root 8, just like you see it here. And if you're doing parentheses, make sure you close the parentheses. I just went out to the side. And then plus 3 root 50. Hit enter. Now it gives you this crazy number. All you have to do after you type in the original, type in your answer. 23 times root 2. They're the same thing. That's how you check it. Does that make sense? Alright, do number 3 on your own. You can check it with your calculator. This is what you'll have a checkpoint on.
Yeah, all of these are first grade. I can go into them, yeah. It's not first grade. Or first grade. Start with small. 1st grade. 2nd grade. 3rd grade. 4th grade. 5th grade. And just go down the list again and then
Alright, let's go over it. 12. Daniel, what'd you break that up into? Good. Yeah. Alright, Victoria, what'd you break 27 up into? Okay. Good. Summer, what'd you break up 128 up into? 64 and what? Very good. Alright, let's simplify. Lucas, what's this one going to be? Alright, Jillian, what's the next one going to be? And Ashton, what's this last one going to be? Root. Alright, any questions about that part? Alright, so which two can we combine? Yes, so that would make what? Can I combine these two? Because they have what? different numbers underneath them. Very good. Questions? Easy? Yes, go ahead. Square root of 4 is going to be what? 2. So you multiply that by that 5 to get 10. Any other questions? Yes. Oh, right here? Somebody help her out. 6 and 2 aren't what? Yeah, one of them has to be a perfect square. Any other questions? Alright, so that's adding and subtracting. Now on to multiplying. Alright, remember when I asked you could you add x plus y and you said no? Can I multiply x times y? And just get xy, right? So with radicals, it doesn't matter about like what's on the inside. You can multiply this or what's on the outside as long as they have the same root. That's all they have to have. Same root. Everything else is fair game. So like on number 1, they both have a root of what? 2. It's not there, it's 2. So we can multiply these. Let's start with their coefficients. What's that going to give us? 24 square root of 16, c to the 4th, d to the... Good. Remember that you add exponents when you multiply letters together? Yes, simplify. So what's square root of 16? We're going to do what with that out here? So that's going to give us... Very good. What else? So c squared and d to the... Very good. Miss anything? Very good. Try the next one, too, on your own.
Just go right and then right. Right, right. Just two. Go over it. What you got? Good job. Alright, when I multiply these together, I will get 6, 4th root of x to the y to the
All right, from here, 4 through to 16. Perfect. Don't forget this isn't a square root. So 4 through. If I didn't know this, I could type what in my calculator? 16 to the 1/4 power. So that's 2. 2 times 6? 12. What's the 4 through to x to the 8th? Good. And y to the... Good. And what else are we missing? Perfect. Everybody good with those? Any questions? Alright, number 3. Don't let me down. We're multiplying here. What are we going to do?
Subtract 26 to the negative 5.
Yes! Thank you. How do we know that we're folding on this one?
It's binomial.
Yes. This is 2 terms separated by the minus sign. This is 2 terms. So 2 terms, a binomial times a binomial will have to fold.
Oh, so you can't subtract because of the root.
Correct. Very good. Alright, so first terms. Remember we can multiply what's on the outside and what's on the inside. So I'll have 12 root of perfect. Alright, outer. What will I have? Perfect. Alright, now this is kind of different than what we've been doing. Think of this negative 5 as having a square root of 1. You can only multiply this 5 by the what right here? The outside. So it'd be negative root 5. That's very important. The 5 can only be multiplied by the coefficient because it is a coefficient.
Negative 20.
Yes, and last one would be negative 20 root 2. Alright, looking at all of these, are there anything underneath the radicals that we can simplify? For example, any perfect squares that go into 15? Any that go into 6? 5? 2? Can we combine any of these? Very good, because they all have different numbers underneath the radical. Done?
No, why couldn't you just, the 12 root 15, why couldn't you just divide everything by 3 and then it equals...
Good question. He said, why can't we divide everything by 3? When we're dividing something, what are we dividing? What's inside the radical or what's outside? Outside. Just what's outside. Because this is not 15. This is square root of 15. That's going to be different. Does everybody see that? So can I divide 12, 24, 10, and 20 by 3? Nope. I could divide 12 and 24, right? But these two, would 3 go into 10 and 2? I mean 20? Correct. So we just leave it like that. Good question. All right, one more together. My first terms, tell me what that'll be. 28 root 12 plus 21 root. Very good. Very good. And my last? Close. Yes. Alright, I'll give y'all time to process that. Remember, what's on the outside we can only multiply together. What's on the inside we can only multiply together. Can we simplify these roots? Yes. Alright, so what goes into 12? Very good. What about 24? 4 and 6. What about 18? 9 and 2. Good. What about 36? Just 6, right? So it'd be negative 9 times what? Just 6. Alright. Square root of 4. What are we going to be doing? Alright, so 2 times 28. Square root of 3. Plus. Perfect. Minus. Root. Good. Minus. 54. Very good. Can we combine anything? Nope. Very good. What do y'all think so far?
Wait, you could divide that by 2.
We could divide everything by 2?
Yeah.
Yeah, you could. But you can just leave it like this. I'm not going to make you divide by 2. No. Alright, so what's going to happen tomorrow, as soon as you come in, you'll have a checkpoint on adding, subtracting, and multiplying radicals. That's what we just did. Remember, add, subtract have to have the same root, same thing underneath the radical. When we multiply, they have to have just the same root. Tomorrow we'll learn how to divide radicals and rationalize the denominator. Y'all have any questions about this? Alright, last thing I'm going to do is pass out some papers that I've graded.